Welcome back to Fun with Data. We're doing the sequel of Python, Pandas and Space Rocks because last time I created this graph of the first 10,000 asteroids ever discovered, and it's great. We read the file with Pandas, we created the graph with matplotlib, all cool, but these are only the first 10,000 asteroids ever discovered, and I had a data file with all asteroids discovered up to now, up to last week to be sure. And yeah, that was a whole problem to read that file. So I wanted to come back to you because I got that working now. Also, the idea rose to do something with machine learning algorithms to find clusters of asteroids in this plot, because as you can see, there are clearly some blotches in here. So I was hoping to do something with that, and I already done it also, so we're gonna see that as well. So we have a whole lot of stuff to do. Thing was, reading the file, that was the hardest problem. I was thinking, how hard can it be to read a file? This 430 megabytes. But unfortunately, it rose memory error after memory error after memory error. And yeah, let me talk to you about when you run Python. Here you see a screenshot of the task manager, Windows Task Manager, where I run Python, and you can see that there's a Python process running on 17.3%. It's using a certain amount of memory, but that memory will rise, of course, when you're using more and more and more of it. At a certain point, every time around 2 gigabytes, it was apparently too much. I have 16 gigabytes in my laptop. Nevertheless, it's around 2 gigabytes. It gave a memory error and it was done. So clearly I needed a new approach. But first of all, let's see what we're going to do in this video. First of all, we're going to read all the asteroid data. So that was no small feat. Then we're going to save the data in between as a pickle. You'll see what it is in a moment. Then we're going to make a 3D graph of asteroid data. And then we're going to do the machine learning bit. Now I know that the JSON file has a structure, it isn't comparable exactly to Excel sheet, but here you get a bit of idea of what was in our JSON file. And you can see that there are a lot of columns. So the problem with reading all this asteroid data was there is so much of it, and there's so many attributes or columns in this case, because I loaded here in Excel to show you, to visualize this. And the only 3 columns we're going to need for our graph are these ones. So I was thinking maybe I can avoid the memory problem by just reading the A, the E and the I column or attribute instead of all of it. Now the thing is, this was my code more or less previously. So I read the whole file and then I do stuff with it. Unfortunately, I can't tell Pandas to read that file but only 3 attributes. As far as I know, that is not a possibility. So I needed a cunning plan, and this is it. So here's basically the file. I need only those 3 attributes, not the rest, for my graphs. So what I'm going to do is going to use a library called iJSON, and this allows me to go row by row through my data. And every time I read a row, I can pick out these 3 columns, set them aside. And the way we're going to do that is we're going to save it as a Python dictionary. So dictionaries, what are they? They are a way to store key value pairs in Python. So key value pairs, what's the use? Well, here we have an use. We have the keys here, and we're going to use the attribute names as the keys because it's so useful later on when using in Pandas and in graphs, that we already have a name for them. So we have the keys A, E and I, and the values, well, those are the actual numbers, the floating point numbers that we have of these in the asteroid data. So 2.6685 as the semi-major axis A, and so on. So we're going to call that dictionary selected row. Of course, we're going to need to install iJSON. Now about the code. So this code will not be as easy as the previous code I've shown in the previous video. It's not going to be 8 records, unfortunately, but I'll try to explain what is happening. So the first 2 lines where we load the pandas and matplotlib, we done that last time. But now we're also going to import iJSON so we can use it. I decided to store the path and the name of my file in a variable called filename, so I could use it further on. And here I open that file. So this is where I use the Python command with open, and the file name is the first attribute. The R as the second attribute stands for read, and S, and then there's an F, there's sort of a placeholder for the file. And now I can use this in iJSON. And with iJSON, I read that data in a variable called objects. But while this refers to the whole file, it is not reading everything into memory, and that is important. What it allows me to do now is to go row by row through that variable objects, and it will read that row from the file. There we have the opportunity to select only the 3 rows. So I create that select row dictionary here, an empty dictionary every time. Every time it goes through the for loop, it will create an empty dictionary, and then I fill it with some data. Now, probably have to explain this, what is happening here. So here, the A, the E, and the I, these are the keys. And the row A, row E, row I, these are the values that we get from that row that we read from the file. So we actually can choose to pick these attributes only. Now, this would be great if this was only the only stuff I have to explain, but unfortunately, this data will be stored as a decimal data type, and for later on when we try to graph this data, that won't work. We're gonna need a floating point data type, unfortunately. So we have to do a command to change the data type, and this is it. Again, here we have the keys and the values, but now we have a float command around the row where we get the data, where we get the A, the E, and the I data from the A, E, and I attributes. And this works. So, okay, good, but we start with an empty dictionary every time we go through the row. So we need to store our information for later use somewhere. So for this, we do an extra step. We create a list. So here we have all the dictionaries we create for every row. So every dictionary, this is basically what it looks like when you look at the actual data in it. And what we're going to do is we're going to create a list called asteroid data. And a list you create by starting with a square bracket, then put something in that list, then a comma, to then put something else in that list, then a comma and nothing else, something else. And at the end you end with a closing square bracket. Now you can put numbers and strings in a list, but you can also put dictionaries in a list. That's one of the ways that Python is very flexible. And it helps us this time because now we have a list that we can offer pandas to work with it. So we have to change our code a little bit. First of all, we're going to create that empty list, asteroid data. And here we append that selected row, that dictionary, to that list, to asteroid data. And now we can offer it to pandas. And this is a bit strange because the command is dataframe.from_dict. While this is actually not a dictionary but a list, but it works. So I'm not asking questions here and doesn't create weird bugs. I'm happy with it. And we're off to the next step. So now we read all the data and it will take a while, I'm gonna tell you. So it wouldn't be great if we have selected these 3 columns, we could save that somewhere like an in-between answer, and so that we can, if we change our graphs a little bit, that we only have to read these 3 columns instead of all the data again. And such technology exists in Python and it's called Pickle. So we're gonna need to install a new library. And basically this is more or less of our code. I had to leave out all the stuff where we loaded the data. We have to, of course, import the library Pickle, and then we save our data to a Pickle file. So what you see here is we have Pickle out, sort of a placeholder, I guess, that for the fact that we opened this file. We haven't done anything here, but here we dump all our data from our data frame asteroid df on the first argument to Pickle out, and then we close Pickle out, and sure enough, you will find a file in the same directory where you ran this Python code, unless you gave it a different path, where you will find a .pickle file, and it has your data. So that's pretty great. It's helpful because now we can read it, and we can leave all the code that we did before, except the imports of the stuff that of the libraries we're going to need. So let's take a look in my editor. This is called Sublime Text. It's a great editor to work with Python. You see, this is all the code that we are not going to need anymore if we're going to read that Pickle file we created before. So I can comment all that out and just start with reading the Pickle file. So that's great. We've done it. We read the JSON file once. We don't need to do that every time anymore. So now we can create that graph of all the asteroid data. And this is pretty easy. We read the Pickle file and we do the same graphing commands that we did last time in the last video. We run this, and sure enough, there we have it. Now it looks ugly, but it was a long, hard fight to get this working, so I'm pretty happy with this. Do all the asteroids in the main belt look like one big black blotch? Sure. But yeah, at least I got something. Cool. On to the next thing. We're gonna make a 3D graph of our data, because after all we have 3 columns, 3 attributes that we can use in a graph. But to be sure, I'm not going to do this on all the asteroid data, because when reading all that asteroid data from the complete extended file, basically because of, well, memory errors. So what we're going to do is we're going to read the 10,000 asteroid file again. Actually, we're going to read the Pickle, because I created a Pickle file for this as well, which is also useful. And now I'm going to do some magic on creating the graph. Now all these commands I basically copied from the Syntax YouTube channel, where Harrison Kingsley explains perfectly how to make these 3D graphics. What we're going to do here is we're going to load a library called NPL Toolkits, but as far as I know this comes with the matplotlib library, so you don't have to install that one. We're going to use something called Access 3D, and we're also going to load a style from matplotlib because it makes our graph look better. And there are all kinds of styles in matplotlib, but this is one I chose, Seaborn Paper. A very popular one also is ggplot. These are all kinds of graphic styles you can choose. So now we are ready to use the commands for this. I'm not trying to explain everything about this, but apparently you create a figure and a subplot through it, and you can choose as a projection 3D. And now we can create a scatter plot, but not with a plt.scatter, but ax.scatter. And here we can, as you can see, we can choose the 3 attributes: the semi-major axis A, inclination I, and the eccentricity E. And we also can change the limits of our graph. And this command is different from the previous time we did that with the 2D graph. Here we have to use the command set_xlim instead of xlim. And you can work out yourself how the y and the z axis can be limited properly. Also, we're going to create a label. Well, because I don't have enough space on this page, I'm just going to show you how to do the x label. That's also a set_xlabel command, and you can probably work out from that how the y and z label work. We're going to create a title, and then we're going to show the graph, and this is it. This is the graph, and this is a video I created earlier. Here you can see me using the mouse to move around the graph, and doesn't that look just great? You can clearly see the asteroid families in here. You can look at it from the top. You can look at it from below. You can do all kind of stuff. Zooming in, that was harder. Or basically it didn't work. The zoom button doesn't work in the 3D as far as I can tell. And you can see how the labels that I've created also work pretty well. So you really can see where the eccentricity, the inclination, and the semi-major axis are. You also can see that the dots, that several dots fall outside the graph. So I limited the axis, but I didn't limit the data that was plotted in this graph. For this, if you don't want the extra dots outside your graph, you really have to limit the data that goes into the scatter command, basically. But it works. It looks very nice. I was really happy to see this. So now we're going to do some machine learning. Well, this is a statement of the year. Machine learning, yeah, we're going to use some algorithm. Well, let me tell you a little bit, because I've done a presentation about machine learning algorithms a while back, just to show you what we're going to do, what basically is the idea. So here we have a plot with, well, seemingly two clusters of dots, of points in this graph. And we're going to use something called k-means clustering, an algorithm to see if there are two clusters. For this, we're going to use centroids, which we're going to place ourselves, or going to we place randomly, a red one and a blue one. And what you basically say is, now I'm going to divide these dots based on how close they are to either the red one or the blue one. The step we're going to do now is we're going to move these centroids to the average of their cluster, basically, at this point, their own group. So the blue centroid is going to be moved to the center of the blue dots, and the red one to the red center of the red dots. So here we go. Then we're just going to repeat this a couple of times. So again, we're going to divide the dots based on the how near they are to the centroids. And we keep repeating that, dividing the points, averaging the centroid, dividing the points, averaging the centroid, until the centroid hardly ever moves. And now you have two clusters, basically. But the thing is, in this case, we chose two centroids. So we chose that there would be two clusters. What we're now going to use is a little bit more advanced, because we now let the algorithm decide how many clusters there are. For this, we're going to use an algorithm that's a little bit more advanced, and we'll let the algorithm decide how many clusters there are. And for this, we're going to need a couple of libraries. We're going to need NumPy, we're going to need SciPy, and we're going to need scikit-learn. And scikit-learn contains the machine learning algorithms that we can use. But I had problems installing SciPy. I had these problems in Python 3.6. To work around that, you can go to this site, which I put in the show notes, and download the libraries yourself, then install them. So below you see an example, pip install, and you see I have a path called the downloads, and there is where my file has downloaded. And after running this way, I got it working. So now I can do machine learning. So what we're going to do, well, we're going to use a Pickle again, and I'm again going to use the 10K asteroid Pickle and not the whole set because, well, memory. And we're going to add 2 rows to our whole import business. We're going to import NumPy, and we're going to import scikit-learn, what's now called sklearn. And from that, from the cluster algorithms, we're going to use MeanShift. And then that's the one we're going to import. First of all, we can do this algorithm on multiple dimensions. It doesn't have to be 2 dimensions. It can be 3, but we want to graph this afterwards. So I'm going to do this only on the semi-major axis and eccentricity. And I'm going to drop the I attribute, the inclination attribute. Because, well, I'm not going to be able to run all this and make a 3D graph of all this. That's going to cause problems. We're going to run MeanShift like this. Create a thing called MS, and then we fit the algorithm on our asteroid data. Now, if you run it if you run the MeanShift command like this, it will run on 1 CPU core. But if you use this command, it will run on all the CPU cores you have available. So that could be preferable if you want to run it faster. Now we have to do some magic with labels. We have a label variable which we're going to use later to color our different asteroid dots in our graph, depending on what cluster they belong to. And we're going to use make a cluster center variable which will show which cluster centers there are. And here we're gonna print that list of cluster centers, and they're basically coordinates which you can use in your graph. And you can also show the number of clusters. Now we want to show these clusters in our graph. So we're gonna create a color variable with different colors, named as letters because that works. So we have red, green, blue, cyan, black, yellow, and magenta. We want to use more than 7 colors because we can have more than 7 clusters. So we do this times 10. So basically what you will get is red, green, blue, cyan, black, yellow, magenta, red, green, blue, cyan, black, yellow, magenta, and so on. Now we do a for loop, and we're gonna basically go through our asteroids DF data frame, and we color each point depending on what label they have. So you have the label, the color command here, and the labels command here. That didn't work quite well with my experiment, as you will see in a moment. Also, we're gonna print these cluster centers in our graph with a big mark X. And what you see here is what on the x-axis of the scatter command, we're going to use all the cluster centers, and that is signified with that colon. So colon, comma, 0 means all the cluster centers, but only the first part of the coordinate. And then here for the second argument, we have the cluster centers, all the cluster centers, but only the second part of the coordinate. Yeah, so now we can basically graph it like we are used to do. And then you run it and you get, I got 17 clusters in that asteroid data. So these are the coordinates where, according to the machine learning algorithm, are the centers of clusters. And this is what it looks like. So I forgot to zoom in, but you can see where all these 17 centroids are, and you can see that there are some centroids on very far asteroids dots, and I don't think there's even more than one in this graph. So that is not exactly what I want. I want to zoom in, and when you zoom in you can see that basically everything is red. There are no other colors. Now that could be because it just happened to be that it looped around and just landed on red as a color for the second cluster here. But I don't think so, actually. I haven't seen any other color in this graph. I also tried to leave out all the asteroid data from below 2 astronomical units and higher than 3.5 astronomical units. And then I ran it again, and then it found only one cluster. So that was not exactly what I was hoping for. So this is something I have to look into a little bit more, but at least I got it running, and it ran pretty easily. Thanks to, again, pythonprogramming.net and the YouTube channel Syntax by Harrison Kingsley. So we got quite a lot done here. We read a large file. We created a 3D graphic that we can revolve and look around. We created an in-between Pickle file to store our data. And on top of it all, we did machine learning with scikit-learn. So you might ask, what are we going to do next? Well, what's next for me is a holiday. I will go to the United States to watch the solar eclipse on August 21st. And after a while, I will be back and probably full of fresh new ideas how to work with that asteroid data and do wonderful new things with it. Until then, thank you for watching. I'm Marcel-Jan Krijgsman. If you want to find out what else I'm doing with data, you can find it on my blog, Expedition Data. I'm on Twitter. And if you need a data engineer, well, ask me in the YouTube comments or look on opencirclesolutions.nl.